All right, this is your review for topic 3. I have some things at the top that you want to memorize. So if you want to hit pause and record them or open them on the notebook, whichever one you want to do. I've also labeled which section each of these questions come from. So let's get started. All right, so if I want to convert something that's in degree, minutes, and seconds, so that's what those symbols are. The degree stays the same. I then say there are 34 minutes to a degree, which is kind of like the same thing as an hour if you want to kind of think of it in that sense. Plus, there are 42 seconds in a degree, which that means there's 42 seconds in an hour. Let me repeat that. There's 42 in this example. There's actually 3,600 seconds in an hour. Sorry, that's why I do 42 out of 3,600. Calculate those by adding them in your calculator. So if you want to hit pause and try that on your own, that's all you do for that one. I don't have the answer right in front of me, and I'm trying to do this quickly. So if I want to go the other way around, this one's also calculator. If you think about, so the degree stays the same. And then I have 0.34 is like 34% of that hour would give me the minutes. Okay, so like if I had half an hour, that's 30 minutes, right? So 0.34 times 60 to get those minutes. And then so you can use Desmos if you're not sure. So 0.34 times 60, that's 20.4. So that means that there are 20 minutes. And then to find the seconds, so this is, then we have 0.4 of a minute. So if I take 0.4 and times it by 60, that will give me the seconds. So 0.4 times 60 is 24. So 24 seconds. Okay. All right. Coterminal angles are angles that are on a graph. That's terrible. Let's try that again. So if I have this angle, it's whatever that measurement is, but I could also go around the circle a whole time plus some, and notice I'm still at the same start and ending point, so those are coterminal. How do I figure out what coterminal is? I add 360 and subtract 360, and I can do that multiple times because I can go around the circle 5 times and then a little more. So I can keep adding 360 or keep subtracting. So this is negative 620 and this is 100. So the rule there is to just keep adding or subtracting 360. And 360 because that's a full circle, so 360 degrees. If for some reason it were ever in radians, it would be 2 pi. All right. So this is the question where you want to know SOHCAHTOA, one of the things to memorize. So I look at this example. The hypotenuse is always across from the 90 degrees. Adjacent is next to, so this is adjacent. Use SOHCAHTOA, A and H is with the C. So I'm going to set that up as cosine of 39 degrees equals the adjacent over hypotenuse. You got to go in that order, so A and then H. Solve for x by multiplying by x on both sides. Now I don't have a fraction, so life is a little easier. But on this side, if I want x by itself, I'm going to divide by cosine of 39. And what I do on one side, I must do on the other. So I have to divide by cosine of 39 here. So 13 divided by cosine of 39. Scientific calculator is going to be your favorite for Desmos for this. Divided by cosine 39 because it's already in degrees. So my answer is 16.73. Here's what I want to show you though. If I don't change anything in my graphing settings and I do cosine 13 divided by cosine 39, you'll notice I get a different answer and you're like, well, uh-oh. That's because in my settings up here, I'm in radians. I need to be in degrees, and then I get the right answer. So 16.73 hundredths is 2 spots. Okay, and that's the length of the hypotenuse. Number 5 is easier than you think. 0 and 90 with theta in between just means my answer has to be somewhere in between there. If I think of theta as my x, my goal is to get x by itself. So I need to do the inverse of sine to get rid of sine. So sine inverse looks like this. And then that means that they cancel, so I'm just left with theta. But what I do to one side of the equation, I have to do to the other side of the equation. And then from there, it's calculator. Okay. So I get 44.72 degrees because it says to express your answer in degrees. Okay. All right. This next one has the most components to it. Like the actual math we do is not super difficult, but it just has multiple steps, okay? So step 1, graph where that point would be. And when I say where that point would be, I just mean what quadrant. So if you think about where is a positive and then a negative point. So I know square roots throw people off. So let's say that I just graphed 6, negative 5. I would go positive 6 down 5, meaning I'm in quadrant 4. The difference here is that square root of 6 is a different number, but that's my x value. That's how far over did I go. And then negative square root of 5 is how far down did I go. And your angle is always coming out from the origin there. And once I find the hypotenuse, I've got all the pieces of information that I need. So to find the hypotenuse, I'm going to use the Pythagorean Theorem. And I'm going to do square root of 6 squared plus negative square root of 5 squared equals c squared. The square roots and square roots cancel, so that's 6. When I square something, it's positive, so that's just 5. If you don't know that, type it in your calculator. 6 plus 5 is 11 equals c squared. I need to get c by itself, so the hypotenuse is square root of 11. Okay. Now, secant is the reciprocal of cosine theta. So cosine theta, remember, is adjacent over hypotenuse. So that must mean that secant is hypotenuse over adjacent. So to find the answer here, my hypotenuse is square root of 11. My adjacent is right next to, so that's the x value. That's square root of 6. All right, notice none of those answers are it. You could play what I call match the fraction. So if I type this in my calculator and I type all my answers in the calculator and I get crazy decimals, which crazy decimals match? Or I can rationalize. So square root of 11 times square root of 6 is square root of 66. Square root of 6 times square root of 6 is square root of 36. So that's square root of 66 over 6 because the square root of 36 is 6. Cruising right along. We have a ladder. You get to see my awesome artistic abilities here. Very much sarcasm. Here's the ground. Here's the building that it's leaning against. Put some windows in there. Aren't they beautiful? Okay. The ladder is 32 feet. Okay. The angle that it makes with the building always comes from the ground. Okay. And then we want to know how far away is it from the ground. I'm going to change your wording on your test here because I don't like the way that this one's worded. So I will make sure to say, instead of saying this, angle of elevation. That way it's just worded better because this is the way it should be set up, but that wording doesn't make it sound that way, so we're going to change it. Anyway, setup's good. We know the hypotenuse. This is the adjacent. So, and then we have 22 degrees, 37 out of 60 minutes. So I'm going to go ahead and round that using a calculator. Just letting you know I'm not doing anything crazy here. Just what is 37 out of 60 to get the decimal? Oh, that's about 617. So 22.617. I did that quicker than before, but that's basically the same thing that I did in number 2. Okay, and then adjacent and hypotenuse is cosine again. I don't know why on this review. I just love me some cosine apparently when I made this. And it equals the adjacent over the hypotenuse. To get your final answer, multiply by 32 on both sides. That means x is by itself, which is what you want. So 32 times cosine of 22.617. So 29.54. Feet, because we were starting in feet. All right. Keep on rolling. I thought I put, oh yeah, this isn't the same one. Okay, we need a unit circle for this. So this is why it's important to get a 4 on your unit circle. Notice it says tangent is square root of 3. So tangent of some angle is square root of 3. And it needs to be between 0 and pi over 2. So if you go back here and look at our unit circle here. 0 and pi over 2 means that it's in the first quadrant. Right, I'm actually going, let's see if I can get it to work here. Let's copy and paste that into our review here so that I can write all over it. Come on, there we go. Okay, so there it is. Tangent theta is y over x. I will write this over by that problem so that it... So in the first quadrant, which one of these, when I do y divided by x, will give me square root of 3? So I'm going to eliminate the easy one first. Anything divided by itself is 1, so it can't be that one. I'm eliminating that one. Then I have to decide, is it going to be 1/2 divided by square root of 3 over 2? Or is it going to be square root of 3 over 2 divided by 1/2? Remember, that's y divided by x, y divided by x. This one ends up multiplying by 2 over square root of 3. So that's 1 over square root of 3. Well, that's not right. This one, the 2's end up canceling, so it becomes square root of 3 over 1, which is square root of 3. So that one's my answer. So which one has y as square root of 3 over 2, and the x value is 1/2? It's this one, which is pi over 3. So the answer here is pi over 3. Since this part right here was in radians, that's how I know I want my answer in radians. Okay. All right, for my next one here, I want to find sine if cosine is 5/8 and tangent is less than 0. So that means tangent is negative, cosine is positive because this 5/8 is positive. So that means I'm in the 4th quadrant. Remember, all, so everything's positive. Well, that's false. Students means sine is positive. Well, we don't know. T means tangent is positive. That's false. All students take calculus. Cosine is positive. Yes, that one is true. It also follows that tangent is negative in that one. So this is the triangle I'm working with. Cosine is adjacent over hypotenuse. So now we have a problem very similar to, I don't remember what number it was, number 7. Okay? The difference this time is that I know the hypotenuse. So I know c squared. So that means I have x squared equals 64 minus 25, because I subtracted the 5 squared there. So what is that math? Hopefully you know it by now. 39. 39 is prime. We like that because that means I don't have to simplify the radical. It's already simplified. This is square root of 39. We need to find sine theta, so that is opposite over hypotenuse, so that's square root of 39 over 8. 3 more, we can do it. This is another example we definitely want our unit circle for. So I have 4, and then I have sine of pi over 4. I have 2, and then I have tangent of 3 pi over 4. So remember, sine is the y value, so I'm going to come over here to my unit circle. Here's pi over 4, and the y value is square root of 2 over 2. Tangent of 3 pi over 4 is y divided by x. So if I think about that, I'm just going to do the workout here to the side. I have something divided by itself but negative. So think of that as just like, what's 2 divided by negative 2? What is 10 divided by negative 10? What is 1,000 divided by negative 1,000? Well, that is just negative 1. Simplify here. So this is actually like 4 over 1. 4 divided by 2 is 2, so it's 2 square root of 2. And then 2 times negative 1 is minus 2. So that is my final answer there. Okay, when I have that radical, they're different terms, so I cannot combine them, okay? All right. This one, so all students take calculus again. Where is cosine negative and tangent negative? Well, right off, we're like, well, I don't know. But remember, this tells us everything that's positive. Well, it can't be all because we have something negative. This says that tangent's positive, so it can't be that one. This one says cosine's positive, so it can't be that one. It has to be this one, because if sine is positive, that means cosine and tangent are negative. And so if you don't know your quadrants yet, they go in counterclockwise order. And so it is quadrant 2. All right. Last problem. I like to think of this one by doing a right triangle. If you want to find tangent, one of your options is remember the sine is the y and cosine is the x. Tangent is actually sine. All right, sorry that cut me off because I ran out of storage, so I had to delete some crap, and here it is. Okay, so what I was saying was y divided by x, so 6/7 divided by negative square root of 13 over 7 is an option. That if you're good with fractions, you can do that. If you don't like fractions, think of it this way. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So now we have everything we need. Tangent is opposite over adjacent. Oh, I did that wrong. Adjacent being negative square root of 13. So I want to multiply by square root of 13 on both sides. Or sorry, top and bottom, numerator, denominators. I'm trying to quickly finish this. So I get negative 6 square root of 13 over 13 when I multiply straight across. And that's my final answer. If I were to do it the fraction way, it would look something like this, which means that I would multiply by the reciprocal. The 7's cancel, so I'm left with 6 over negative square root of 13, which I just rationalized to get that answer. Okay, there's your review. Done. Yay, team. Good luck on your test.